A problem many software engineers are facing today is in writing good, clean, and well-designed code. The code works correctly and perhaps efficiently too, but due to poor design, the code is not maintainable. That is, it is not easy to understand. And if it is not easy to understand, it is not easily extendable. That's the maintenance problem, and it can be a huge nightmare. By poor design, I mean not following proper design principles and best practices. And this often leads to several rounds of code refactoring or code enhancement, due to which there is loss of valuable time for the company. So with every software release, instead of adding new features, a significant amount of time is spent on refactoring the badly designed code. To a large extent, this has to do with the way we are taught programming, and there are three limitations here. First limitation is, most courses are good at teaching the language fundamentals, but they are still not comprehensive enough and miss out on several important features. Or even if they do discuss them, they are still not in-depth enough. Many times, the focus is on teaching the syntax of a particular feature, but why that particular feature is being taught is not clearly explained. So the motivation or the purpose is being missed out here. Now the second limitation is perhaps the most important one. Almost always they never teach best practices and design principles which are essential for writing high quality code. The third limitation is also very important. Most of these courses do not include an instructor-led project that follows professional coding conventions. Although concepts are demonstrated via small demo programs, but that's not enough. So due to these three limitations, what we have is a sort of incomplete engineer who is pretty good at working on small to medium-sized projects, but falls short when it comes to implementing large, complex features. And this affects his or her confidence levels and also puts a lot of stress on that individual. Now this comprehensive master course aims to address the shortcomings in the current courses, and the main goal of this course is to help you become a complete Java engineer right by the end of this course, and to also help you fall in love with this incredible and robust programming language which for over 25 years has been helping companies to solve some really complex problems. And a complete Java engineer is someone who has a comprehensive understanding of the Java language along with the many design principles, best practices, and professional coding conventions for building well-designed software. This course has already helped tens of thousands of students across over 150 countries, ranging from absolute beginners to even experienced Java professionals. Many top companies are also using this course content as part of their official training programs, and many universities are also using it as a reference material. It is truly one of the top Java courses out there. And it takes a holistic approach to teach Java programming. It covers most of the language features in a very in-depth way. Everything from language basics to object-oriented design to advanced topics like multi-threading, database programming, and functional style programming features like lambdas and streams are discussed in great detail. It's not just syntax, but motivation behind introducing these features is also discussed. And a highlight of this course is we discuss several best practices and design principles that a good software engineer is ought to know. Many design principles outlined in the popular Effective Java book are also discussed, and many of them are actually demonstrated in code using our own custom examples. Top engineering teams like the ones at Amazon or Google would expect you to know these best practices and design rules. Another highlight is that it includes an instructor-led project where we develop a real-world bookmarking web application using Spring Boot with MySQL as the database. The project is initially built using core web technologies like servlets and JSP, and is then migrated into a modern Spring Boot application so that you can clearly see the benefits of Spring Boot. Project also follows standards like MVC and TDD, where TDD stands for Test Driven Development.
So you're going to gain some good real-world experience right from the comfort of your home or the workplace. So these three are the core objectives of this course. Next, we use Eclipse for writing our programs, and a comprehensive Eclipse tutorial is also included, and it teaches you all the things that you need to know as a professional developer, including debugging Java programs and JUnit testing. Finally, we have a special chapter giving a solid introduction to JVM, which stands for Java Virtual Machine, and it is an incredible platform on which Java programs run. Most courses never discuss this topic, or even if they do, they barely scratch the surface. Furthermore, to help you stay ahead in the industry, we have added bonus sections on the popular Spring Framework and Spring Boot, along with a quick Maven tutorial to get you up and running. Several challenging quizzes and coding exercises are included to validate what you have learned. So together, all of these will help you in becoming a complete Java engineer, and if you're complete, it means you're confident and a happy engineer. Only requirement is to concentrate really well, as over half to 1 year of your self-study effort is packed into this master course. It is a sort of mini degree in itself. You can reach out to me if you have any questions, and I will respond within a day or so, and my answers are very detailed and personalized too. And over 10,000 questions have already been answered.
And finally, this is Dhiru Munduluru, and I'll be your instructor for this course. I'm a passionate software engineer and an educator with a PhD in computer science, and I have several years of experience working as a principal software engineer in and around Silicon Valley, developing complex algorithms in areas such as search, data mining, and data integration, where we deal with tons and tons of data, and I have used Java for this, and I've been using it for a very long time. So I have brought all of this experience into this Java Master course. Now, if you have liked what you have just heard from me, and if you want to become a complete Java engineer, then please go ahead and sign up for this course. And thank you for your time, and have fun.